Today we would be discussing Numpy. So let me just share my screen. Okay, here comes my Jupyter notebook. So Numpy, as we discussed yesterday, that was a basic introduction that how we go about. I'll explain you again. Let's take it from the top. So I'll take some time to explain lambda functions as well, like I promised yesterday. So just a brief introduction, just a brief summary about what we discussed about NumPy yesterday. So NumPy is a numerical Python and it is an inbuilt library in Python. So how do we import NumPy? We use import NumPy as NP, where NP is the alias for NumPy. If NumPy is not installed in your system, so if this thing, the line 57, doesn't run on your system, it means that NumPy is not installed. For installing NumPy, we use exclamation mark pip install NumPy, pip install NumPy. That's how you install NumPy, and post that you can run this thing and you can check out if NumPy is working or not. Now, NP is just an alias or a nickname. You can provide any name in place of NP, but the general norm, the general tendency, the general criteria is to use NP as an alias. So we discussed what a 1D array is, what is a 2D array, and what is a 3D array, how they look like, and how do we create an array. So this is a 1D array. So an array of 2D array of 1D arrays forms a 2D array. An array of 2D arrays form a 3D array. We also discussed, so this thing is important. We'll discuss this thing again. So how do we do? Basically, this is nothing but this is indexing in NumPy arrays. So this is how we do indexing in NumPy arrays. Let me just run all these cells. Okay, import NumPy. So I have to import NumPy first. It's taking some time, but it's okay. So any questions on yesterday indexing? We'll discuss indexing again because that is important. So this is a 1D array. So this is how we check the type of the array. So let me just run all these things and then we quickly jump into what is indexing, how we do indexing in NumPy. So yeah, so let's say this is the array that we have. Let me take up a Word document. So in an array, when you are talking about a 1D array, every element has an index 0, and within that element we have different sort of indexing. So like this. So this is a 2D array. This entire thing is index 0, and this entire thing is index 1. Now within this index 0 we have this as the index 0, so in this index 0 we have all these things. This is again within the index we have further indexing. This is 0, this is 1 index, this is index 2, and this is index 3. Similarly goes with this part as well. So when I'm saying ARR 0, it means I get this thing. This is equal to this thing. And when I say ARR 0, and within this I am doing indexing, let's say I say 0, I will get 1 as the output. Fine. If I say ARR 0 and 1, so within ARR 0, this is my ARR 0, I am pointing to index 1. So this is index 1 for me. I'll get 2 as the result. Similarly, we go ahead with other dimensions as well, other ND arrays as well, other 2D and 3D arrays. I'll just explain you the 3D array, which is a complex one. So just taking 2 minutes more on this previous thing that we studied yesterday, because this is quite important. So let's differentiate this thing: 11, 12, 13, 14, sorry, 22. Let's take it 100, 200, 120, 11, 10. So this part is this entire part. This is index 0. This is index 0. So this will return me, if I say index 0, this will return me this part of the session, this part of the thing, or whatever you say. It will give me this as the output. If I say index 1, it will return me this as the output. So now when I say index 0, when I say ARR 0, so I get this thing. I get this as the result. But what if, but these are again separate arrays. So every array has its own index. This is again index 0. So when I say ARR 0, again 0, so I get this thing, the first one. Get my point? I get first one. Now in this, there is further indexing. This is 0, this is 1, again the same drill, same thing that we have done earlier in lists and everything. So when I say this part, so let's say I need to go to index 0, 1, 2. Let's say I go to index 2. So it will give me 3 as the result. That's how indexing is done. Now if I do the same thing, ARR, let's say I go to index 1, then I go to index 0, then I go to index 3. What would be the result? Now index 1, this thing is index 1. Now 0. So in this index 1, this comes out to be the index 0. Now third in this. So 0, 1, 2, 3. So I get 14 over here. So that's how indexing in Numpy arrays or in ND arrays work out to be. Now we have certain things, certain criteria, not certain criteria, there are certain functions. Yeah, we studied this function np.arange. So it is a random thing that we can generate an array providing a direct number to it. It will pick up all those numbers and generate an array for me. It's simple. It's just a range that I'm providing. That's it. If I'm not providing any starting element, it starts with 0. So that's why over here it is 0. When I'm providing 1, it will take it 1 as a starting element. And the end is end minus 1. So 5 minus 1, I get 4 over here. Over here 42 minus 1, I get 41 over here. That's how indexing works in Numpy arrays. Now we have certain things like there are certain factors, certain dimensions. If I want to check out what is the dimension of my array, so I have ARR1. This is my 1D array. Let's say I want to check out its dimension. So what I can do is ARR1.endim. So this gives me one dimension. Let's say ARR2.endim. So this is a 2-dimensional array. ARR3.endim. So this is a 3-dimensional array. We have already created these arrays. So this is something where I'm checking how to check the dimension of a Numpy array. Understand? So endim is the keyword. Endim is a function or whatever you call it that helps us identify that what is the dimension of that particular Numpy array. Fine. This is a small keyword endim, which is ND array or Numpy dimension. This is how I have remembered it. There is no such way to remember it. So when you say n dimension, or you can say Numpy dimension, so I need to find out the nth dimension of my array. Which is the what dimension of this array is it. So what is the dimension of this array? So n is like 1 dimension, 2 dimension, 3 dimension, 4 dimension, like that. So we have n dimension. So n dim, that gives you the dimension of the numpy array. This is just how I remembered. I'm just imparting the same thing to you. I'm just transferring the same thing to you, that this is a way you can remember this, because there's another terminology as well which is similar to it but different, that gives us a different result. So let's say now the next part is, we have already covered the indexing part. Now let's say I need to create an array, let's say an array A, or let's say let's take array A. So I create an array np.array, just like we created earlier. So I'm passing an array over here, 1 2 3 4. I don't know why I take this example 1 2 3 4 over and over again, but this is something that comes up automatically to me. You can take anything that you want to. Let's say I want to give a dimension to it. I am creating an array, but I want to change the dimension of the array. So there is something called, which I can do, which is, one was ndim, now this is ndmin. So it's just in adding n to ndim, sorry, ndmin. So n dimension, I'm defining the dimension to my array. Let's say I give a dimension 5 to it. So when I print A, so I get dimensions like this. So this is 1 dimension, this is 2 dimension, this is 3 dimension, this is 4 dimension, this is 5 dimension. So that's how. So if I'll check the dimension of my array now using a dot ndim, this one, the same part, it will give me 5 as the result. Let's say let's take it to 2 dimension only, or let's take it to 1 dimension. So in 1 dimension I'll just get 1 bracket, and if I check the dimension of it, it's 1 dimension. So it's just a way, if you have multiple arrays and you need to define a dimension of an array. So that's how we do it. I'll just give a title to it, so that once you're referring to the session, you have an idea. So an array can have any number of dimensions. So if I say any number of dimensions, if I say it's a 5D array, so it's a array of 4D arrays makes a 5D array. Just like a 3D array is array of 2D arrays make a 3D array. Similarly, an array of 4D arrays make a 5D array. So when an array is created, we can define the, again spellings, we can define the dimension of an array using the keyword as ndmin. So you get my point? This is how we define the dimension of an array. Now this is nothing, just take it light, it's not something important. Now comes an important thing. Let's say I have, this is my array. Why? Okay, this is my array 2. This is my 2D array. So if I say A0, or I am dividing it into 2 arrays, let's say I take ARR2 ka 0th index, and I create another array B equal to ARR2 ka index 1, and I print A and I print B. So I have these 2 arrays with me now. So A is an array, B is an array. Now if it would have been a list, let's say L1 is equal to 1 2 3 4, just try to understand it with an open mind. 10 20 12 11. Now can you tell me one thing, can I do this thing L1 plus L2? Any one of you, it's an open question to all of you. will L3 equal to L1 plus L2, add the elements and give me the result? Each one of you think for a minute and give me an answer. I need an answer for this thing. So Abhishek, will L3 be equal, L3 give me a sum of L1 and L2? Just yes or no. No judgments, because I'm teaching you. This is something that you don't know. But what do you guys think? Abhishek, will L3 be equal to L1 plus L2? Will it give some result?
I think it would give a result.
Sorry?
I think it would give a result.
Okay. Uday, will it give a result to me? I don't know who all are there in the class. Let me just, yeah. Uday, yeah, Uday. Will this give me a result? L3 equal to L1 plus L2. Will L3 have some value in it?
Yes, sir.
Okay. Now, Rushmita, will this give me any result? L3 equal to L1 plus L2?
I guess yes, sir.
Okay. Harshita, what about you?
Yes, sir. It will give.
Okay. So let's run this thing. Fine. Let me check what L3 is. So it doesn't give you a sum. It concatenates both the lists. See, it is not giving me 10 plus 1 11, 20 plus 2 22, 12 plus 3 as 15, 11 plus 4 as 15. It is not giving me the result. But now I have A. See, A is this and B is this. Now let's say I create a list C equal to A plus B. Not a C list, but an array. Let me print C for you. See, this will give me an element wise sum. For list, like when we wanted an element wise sum in a list, we used to do this thing. L3 is equal to L1I plus L2I for I in range length of L2. And when I print L3, so when I print L3, then I get a result. I have to check it out element wise. Over here I'm picking up every element of every list and adding that and putting it into another list. Understand? But I can perform the same task with Numpy directly. Just give A plus B, like 2 plus 3 is equal to 6. Similarly, 2 plus 3 equal to 5. Similarly, Numpy arrays work like that. Let's say I have ARR1 and so print ARR1 and print ARR2. So if I say ARR3 is let's say another array is equal to ARR1 plus ARR2, this will not give me a result. This will do, see what ARR is. ARR1 is 1 2 3 4. ARR2, it is 1 2 3 4 10 12 11 12. Why this is not adding it up? Because the dimensions are different. Similarly, like if I have 12 oranges and I have 12 apples, you can't add apples to oranges. Apples can only be added to apples. Oranges can only be added to oranges. You understand? If I have 2 pencils and I have 4 pens, can you add 4 pencils and pens? No. Those items should be same. Addition happens only if the the type of the item is same. Right? So a 1D array can be added to a 1D array, a 2D array can be added to a 2D array, a 3D array can be added to a 3D array.
Sir, can we multiply there?
Yeah, we can multiply it. So let's say I'm coming back to the same example, this one, which was the easiest one, which we picked up. So this is the thing. So this is the array that we have. Let's say C is equal to A into B. This will give me element wise print C. This will give me element wise multiplication. So 10, 2 into 20 is 40, 3 12s are 36, 4 11s are 44. So you can perform division as well. This is equal to, let's say I divide b by a because smaller, larger. So I'm taking that, print c. So see, it gives me a division as well in decimals. So that's how you can perform all the numerical operations directly when you are playing around with NumPy arrays. Why? Because NumPy is numerical Python. So all the numerical operations can be handled directly when you are when you are working on a NumPy platform, or you are working in a NumPy library, or when you are working with NumPy arrays. Now let's say I have list equal to 1, 2, 3, 4, 5, 6, 7, 8. Fine. Let's say I need to convert this list into an array. So what I can do is a is equal to np.array, and I pass L to it. When I print a and also check type of a, let's see what it gives me. See, it has converted it into a NumPy array. So the thing why I have typecasted it. So this is typecasting into an array, into a NumPy array. So when you are typecasting, so let's say you want to perform addition, subtraction on a list. So it would be difficult. You'll have to do either list comprehension, or you'll have to create a function, or you'll have to create a for loop to traverse through a list, put it into an empty list, append the addition or subtraction or multiplication or division of every element of a list, and append it to an empty list. So that's what we have been doing. What if you just convert it into an array and just perform a plus b, a multiplied by b, a divided by b, a minus b? So that makes your life easier. So let's say I have this array now, a is an array. Let's say I need to convert it back to a list. I don't know whether this can happen or not. I'm just checking it out. So don't mind if you get an error. So I get a list back. Let's say I have L1 is this, and I have L2 equal to, but mind it, both should be of the same length. You can't add 10 items in one list and 12 items in another list. So 10, 20, 30, 40, 50, 60, 70, 80. Right. So let's say we have another array, b is equal to np.array for L2, and this is for L1. So print a comma b, print type of a comma type of b. So now we have these two arrays. Let's add them up. So c is equal to a plus b, print c comma type of c. See, these are added now. Let's create a list now. So L3 is equal to list C. Let's print L3 comma type of L3. See, it's so easy. You got the sum right there within few steps, rather than writing a function, creating a function, or creating a list comprehension. So NumPy allows you to perform all the mathematical calculations in just a go. So that's the advantage, one advantage of NumPy. So what NumPy does is it performs element wise calculations. If one array, always remember both the arrays should be of same size. Let's say I've already shown you. So array 1 and array 2 could not be added. Where is it? Yeah, could not be added. They got concatenated. They got joined. Understand? Because array 1 is one dimensional and array 2 is two dimensional. So they couldn't be concatenated. Let's say I have another two dimensional array, let's say 2D array, let's say is equal to sorry, I have to give it in parenthesis. So let's say 1 100, 200, 300, 400, comma, another one, let's say it is 250, 350, 111, 235, anything. Let's take it B only. I always find difficulty in defining an array. Okay, so I have this array. I have array 2. Let's create another array E, which is equal to ARR2 plus D. So what it will do is, this 100 will get added to 1, 200 will get added to 2. So it's element wise within that particular index. So I will get 101, 102, 103, sorry, 101, 202, 303, 404. Over here I'll get 260, 370, 111 plus 12, 235 plus 11. Why should I calculate these things? So that's how you add arrays. That's how you perform addition, or you can perform multiplication as well. E is equal to ARR2 multiplied by D, and then print E. So that's how you get the multiplication of these two arrays. So it is that simple. It makes your life quite simple when you're performing any operations. So indexing is clear to you guys. Addition, subtraction, and creation of array I have already explained. Any questions on this? Or any other calculation that you want me to perform? Sorry?
No, I don't have any.
Okay. Uday, Rushmita, Harshita?
No, sir. Nothing, sir. All clear.
Okay, good to know that.
Thank you.
Uday, clear है सब?
Yes, sir. सब clear.
बढ़िया दोस्त. So अब चलते हैं. Now let's proceed further. अच्छा, just for the sake of my understanding, all of you understand Hindi?
Yes, sir.
Okay, great. Because I don't know Telugu, so I can talk only in Hindi or English. And if you guys want, I can talk in Punjabi as well. So we have now next part is, we have done indexing. How about we do slicing now? So let's say this is ARR2. Let me add some rows below so that it becomes much more clear. Yeah. So let's slice this array. How do I slice this array? Let's take it on 1D array first. Let's say I need to slice this array. So it's 1D array. Accessing a 1D array is similarly just like you do in a list. There is no more difference. 1D array is just like a list. So if I slice my array, so ARR1, if I slice it, let's say I slice it from 1 to 2. So it will start from index 1, 0, 1. It will take this index, and 2, less than 2 minus 1. It will go till 1 only. So I'll get only 2. Right? Let's say ARR1. Let's slice it from 0 to 3. So I'll get end minus 1. So I'll go till index 2 only. So 0, 1, 2. So I'll get 1, 2, 3. Clear? There is nothing what I have not told you earlier. It has already been discussed in lists. So if I say ARR1 and I don't give the starting point, it will give me the same result. It will take it as 0 only. That's how we do slicing. We've done slicing in strings, we have done slicing in lists as well. So this is how slicing in 1D array happens. So what we are discussing over here is slicing in Numpy arrays. Let's take array 2. So this is a 2D array. How slicing will happen in a 2D array? So the normal trend, not trend, normally what we do is, see over here what I'm doing in this part. Let's focus on this line, block number 57. What I'm doing array 1, I'm providing it the start, I'm providing it the end, right? So now over here, let's say array 2, let's say I want to slice only this part of the array. Fine. So what I'll do is, I'll start with the first index, I'll take 0. Even I have to check this thing out. So let's say I'm slicing this one, the first index of a 2D array. So this thing will give me 1, 2, 3, 4, right? Now I want to slice this thing further. From this I want to extract some elements. So what I'll do is, I'll pick up first index, I'll put a comma, then I'll slice this index. Understand? How would I slice? Let's say I say 0:3. So what it will do is, this 0 part is for selecting the index from the 2D array. It will pick up a dimension. So ARR0, first it will execute ARR20. It will give me this part, which is a 1D array. It will pick a 1D array. Now I'm performing slicing on the 1D array like we did over here. Clear? So when I'm slicing over here, it's 0:3. So it will pick 0, 1 and 2. So the output would be 1, 2 and 3. Now let's say I want to slice the other dimension. I want to reach out to the other dimension. What I will do is, first I will say which index I am going to. So this is index 1 for me. Clear? So I take index 1. What the heck? ये क्या हुआ यार? मेरा array कहाँ चला गया? नहीं, fine, it's okay. Let's say this is ARR2. Yeah. So now what I'm doing is, I want to slice this dimension. So how to access this dimension? I say 1. Fine, I get this dimension. Now I'm slicing on this dimension. Let's say I take 1:4. So what it will do is 1, 2, 3. There is no 4. So I have to provide it, let's say 4. So it will go till 3. 0, 1, it will pick 20, 2 and 4 minus 1. It will go till 3. 1, 2, 3. The output would be 20, 12, 11. See, the output is 20, 12, 11, 10. Okay. This didn't work. This is okay, sorry. So when you are exceeding the count of the array, you won't get the result. This is a new thing for me as well. See, it is 0, 1, 2, 3. Fine. So let's say I want to access up till here. So what I'll do is, I'll leave the end of this part and run it over here. If I'll give any dimension over here, I'll get the same result. If I'll put anything over here, I'll get the same result, because it is exceeding my length of the that array, that dimension. So the length of this dimension is 1, 2, 3, 4. It is 4. I cannot go beyond 4. So let's say I take it 3. So I'm getting 10, 20, 12. Let's say I go till 4. So I'll get all the elements. But if I'm saying 1 to 4, why I'm getting, yeah. So it is giving me 20, 12 and 11. Understand? Is indexing clear in 2D arrays?
Yes, sir.
बहुत ही हल्का सा ये ऐसा है यार.
Yes, sir.
ये हुई ना बात. Indexing in 2D arrays. If you are getting bored at some point of time, tell me, not a problem. So what next should we discuss? From a 2D element, slice element from index 1 to index 4, both elements return index 2. Okay. Let's say if I do something in reverse. Let's say if I reverse this thing, what would I get? Let's say I do this, comma 1. So what it is doing is, it is slicing 1 comma 4 no, from both the elements return index 2. Okay, now what this thing is doing, this is what it represents basically. When I'm typing this thing first, the colon part first, the entire thing changes. So what I'm doing is, see, just like Uday mentioned yesterday, that this is like a matrix. So what is a matrix? Matrix is set of rows and columns, right? So when I'm passing anything like this, so first thing is row and the second thing is columns. So let's say my task is, I'll explain you what the task is. So when I'm typing ARR 1:4, so it is 0th row, first row ka, from the first row I'm picking up the 4th element. So let me type this thing first and explain you what it is happening. ARR2 1:4. So
सर कोलन नहीं है तो नल होगा वैल्यू.
नहीं, आई एम ट्राइंग टू एक्सप्लेन यू समथिंग एल्स उदय. So it's like row 1, 0 to 1 to 4, 0, 1, 2, 3, 11, and let's say if I put 1 over here, so I get 20, 0, 1. So let's say okay. So now I remember, now I recall, because these things we don't use on a regular basis, so I'm sorry for a little delay. So what it does is, let's say ARR2, so we have rows comma columns. Try to understand this thing, forget the slicing part. This is a new thing that we are discussing, don't confuse it with slicing. Let's say somebody asks you, get me all the elements in column 2 from a 2D array which is ARR2. Get me all the elements that are present in column 2. Fine. Let's say it says get me this value 20. Just the value 20. So there are two ways to do this thing. One is the way that I already told you, which is ARR2. What we'll do is we'll reach out to the first index, we'll put a comma, we'll take it from we'll put 0, 1, we'll put 1:2. So this will give me 20. But let's say I just want to access the element directly. So let me just type array, let me just bring array2 again here for you. So let's say I want to access this element directly. So what I can do is array2, I'll define the row for it, which is row 1. From row 1, I'm accessing this entire row. So it has 4 elements in it. And from all these 4 elements, the index that I'm picking up is this one. So this is index 1. So it will give me 20. Or let's say I'll type this again, I'll explain you again. So this is the row, this is row 0, this is row 1. I picked up row 1. I am covering all the 4 columns, 1, 2, 3, 4, and from all these 4 columns I am just taking the value 1, the index 1. So this is index 1. Let's say I take it as I take index 0. So I'll get 10 as the result. So this is how I can traverse through the entire matrix without going into a particular dimension. Let's say I want to access this thing. Let me try this thing out for you guys. So let's say I want to pick up 2 and 20 as the answer. So what I can do is I can take it from let's say all the rows and columns, and I pick up 1. So when I'm saying nothing over here, it means it is picking all the rows and columns of it and going through column 1. So this is index 0, this is index 1. You can take it as a column, you can take it as an index also. This is index 0, this is index 1, this is index 2, this is index 3. If I type index 3 over here, I'll get 4, 11. Let's say take another example, ARR 3. So this is a 3-dimensional array. Let's say I want to access this element, just 2 over here. What I can do is, there are 2 ways to do this thing. One is I'll go to the dimension first, or the another way that I have told you right now, slicing through rows and columns. So this is row 0, this is row 1, this is row 2, this is row 3. Let's say row 2. Let's go to row 2. So okay, how will we go to row 2? Let me check this thing out. So this is all the rows. This is giving me this. Okay, let me just edit this thing. Let me create a new array 3, because it is difficult to identify when you have everything over here. Same thing. Where is my array 3? Yeah, this is my array 3. I have both the dimensions same, though that is causing a confusion. I don't know which dimension it has picked up. So what I'll do is I'll just edit it. Let's say this is 10. No. So when I'm doing ARR 3 colon 2, sorry, this gives me the entire array. Wait a second, let me see how slicing is done in a 3D array. I'll explain you guys. Let me just explain you through 2D array only. So we have array 2 over here. So ARR 2. Now let's say ARR 2 ka 0th index is 1, 2, 3, 4. ARR 2 ka first index is 10, 20, 12 and 11. Now ARR 2, if I say all rows, when I am not defining anything over here, it means all rows, and when I am not defining anything over here, it means all columns. So now over here I can define a column which I want the value from. So let's say 0, 1, 2, column 2. So it gives me 3 and 12 from here. If I say column ARR 2 colon comma column 3, I will get 4, 11. Fine. Now let's say ARR 2. Now how we did slicing was, slicing is a different thing. First we go to a particular index. So we reach out to index 1. So we go to index we go to index 1. What is my ARR2? So we go to index 1 and then we slice it. So when we are slicing it, so let's say I am giving it value, let's say I want just 11 from it. I just want 11 from it. So this is 0, 1, 2, 3. This is my third element. So what I'll do is I'll start with 3. Sorry. I'll start with 3. I'll end with 4. So this will give me 11. So what I did was I started with third element 0, 1, 2, 3. I wanted third element, so I am taking 1 less than from this will be 4 minus 1, 3. So it will give me the third index only. So this is slicing and this is traversing through an array. There's a difference. So let's say array 2 and we provide row, let's say row 1, and I'm taking all the columns from it. I'm not providing any mention of it, any value over here. So it means it is taking all the columns. Fine. And let's say from all the columns I want just 3. So 0, 1, 2. So when I'm putting, when I'm putting 2 over here, I'll get 3 as the result. Sorry. So I'm going through row 1. So this is my row 1. I'm taking all the columns in the row and I'm picking up the second element 0, 1, 2. So it gives me 12 over here. Understand? So let's say I'm taking all the rows and only second column. So all the rows means this row and this row both are included, and I'm taking second column. So this is my second column and I'm taking the second index of it. So I'll get this one, second column 0, 1, 2. Understand? Is it clear?
Copy.
Huh?
It's quite related to one each other in every single task.
Yeah.
Just that how you portray it,
Yeah,
the time of
it's,
task.
but you need to understand where you are defining your rows and columns. You understand?
Yeah,
Fine. If
yeah.
I'm putting,
It's like
if
it
I'm,
just think I'm just from that time I'm just making tables inside there itself, like we did in SQL. So the rows and columns, that's how you coordinate and that's how you pitch for them to complete the task. Then it's easy. Like that's my way of understanding. I'm not sure about others.
anyway, whatever way you understand, it's rows and columns only basically. So,
Yeah.
let's say ARR2 and I'm picking up. Um,
Shall we pick two columns together
yeah, that's what I'm
at the
doing
same time?
right now. So not two columns, I can pick a row and a column. So let's say I just want this part to be printed 1, 2, 10 and 20. Fine. So this is all rows. So I'm taking all the rows, but I'm limiting it to 0, 1, column 1. So I get 1, 2, 3, 4. All rows. Sorry, this is just slicing. So I'm taking it as all rows, column 1 ni 0, 1. Let's say I'm taking two columns over here and I'm taking the result as let's say what this gives me 312. Okay, if I say 1 comma 2, it doesn't work. So yeah, this is what I wanted to show you guys. So what this thing is doing, it is taking all the rows. So all the rows means this row and this row, all the rows are being taken. It is going up till second column only. Fine. 0 1 2, it is going till second column. And what values is it picking? Column 0 and column 2. So column 0, which is 110, column 2 is 3 and 12. If I say, if I put it in a different way, let's say I'll take array 2 again. So what I'm doing is ARR2, I'm picking all the rows and I'm taking first two columns and only first two columns, and I'm taking column 0 and column 1. So 0 comma 1. So this will give me 1 10 2 comma 20, 1 2 10 20. So this is how you can play around with this thing, slicing, indexing and everything. This is how you can play around with slicing, indexing and traversing over rows and columns into a numpy array. So I guess I stop over here. This is too much to digest for today. Also, one more thing, if you want to check the data type of an array, type of array is something, is it a list or is it a set, it is a dictionary or something like that. Let's say I want to check out the data type, it's an integer or a float. Let's say d type, that is data type of ARR2. Oops. D type is not defined. Oh, sorry. It is like ARR2 dot D type. Run. Yeah. So it tells me that it's an integer. Let's say if I have ARR1 equal to like 2.2, 2.3, and I check ARR1 dot D type. So it tells me it's of a float type. Let's say I have ARR equal to np dot array. Let's say I'm just trying it out. If I have Avin, comma Rakshita, so and I check ARR dot D type. Sorry, ARR dot D type. It should tell me it is U8 is, it's a string notation. So it is user defined 8. 8 is it's basically a computer defined notation of telling that it's a string data type. So I stop over here.